Very good morning to everyone. In this lecture, EC 8351 Electronic Circuit 1. So, in previous session, we have studied the biasing of discrete BGT. So, the continuation of this session in various biasing of BGT, the type of voltage divider bias. So the bias is provided by three resistor R1 and R2 and RE. So the resistance R1 and RE R2 act as a potential divider, giving a fixed voltage to point B, which is base. If collector current increase due to the change in temperature or change in beta, the emitter current IE also increases, and it reducing the voltage drop across the RE increases, reducing the voltage difference between the base and the emitter. So we have to see the picture circuit diagram of voltage divider bias in the BJT configuration. Due to the reduction in base emitter voltage, the base current IB, and hence the collector current IC also reduced. So here the circuit analysis of voltage divider bias. So we have to see the voltage divider bias in the R1 and R2 and RE. Here the circuit analysis of base circuit. So the base input voltage is applied to the base side. So the voltage across the R2 is the base voltage. Applying the voltage divider theorem to find the base voltage, so we get the equation base voltage is equal to R2 of I divided by R1 of I plus IB plus R2 of I, so into VCC. So here the R2 of I is a voltage input base voltage. So we have to simplify that equation. The base voltage is equal to R2 divided by R1 plus R2 into VCC. Now we can move to the output side, it is a collector circuit side. So the circuit is shown in the output side of collector base voltage. So we have to find out the emitter voltage. So the voltage across the emitter resistance can be obtained as the emitter voltage is equal to IE into RE equal to VB minus VBE. Here IE is equal to VB minus VBE divided by RE. So we can applying the Kirchhoff's voltage law to the collector circuit. We get the equation of collector emitter voltage is equal to the supply voltage minus the collector current and collector resistance minus emitter current and emitter resistance. So the simplified circuit of voltage divider biasing, the base resistance can be calculated the R1 plus R2 divided by R1 plus R2. This is a Thevenin resistance. So the applying the Kirchhoff's voltage law to the base circuit, the Thevenin voltage is equal to base current into base resistance plus base emitter voltage plus emitter current and emitter resistance. So we can simplify that the Thevenin voltage is equal to the base voltage plus the base resistance plus emitter resistance into the base current plus collector current into emitter resistance. So we can simplify that we can get the base emitter voltage in the voltage divider bias. So the base emitter voltage is equal to Thevenin voltage minus RB plus RG into IB plus minus IC into RG. So we can find out the problem 1. We can see the circuit diagram. So here the current amplification factor is equal to 100 for the silicon transistor. It calculates for the collector emitter voltage and also the collector current. Now we can apply in the Thevenin voltage is equal to R2 divided by R1 plus R2 into VCC. So here the circuit diagram of voltage divided bias. So the Thevenin voltage is equal to, find out the parameters, 5 into 10 power 3 divided by 10 into 10 power 3 plus 5 into 10 power 3. So the Thevenin voltage is equal to 3.3.3. So this is 3.33 voltages. So now we can apply in the Kirchhoff's voltage law to the base circuit. So we can find out the base current. So what about the base current? IB is equal to the Thevenin voltage minus base emitter voltage divided by base resistance plus 1 plus beta emitter resistance. So here the base resistance or base current is applying the parameters. So now we can analyze the fundamental equations. The IC is equal to beta IB. So the IC is equal to 1 plus 4 plus 886 milliamps, and then the emitter current is equal to 1 plus beta into base current. So the IE is equal to 4.935 milliamps. Applying the Kirchhoff's voltage law to the collector circuit, so we can find out the solution of the gate source voltage or gate emitter voltage. So in this session we are discuss the various biasing method of BJT for voltage divider bias circuits. Thank you for watching this video.